Welcome back, Math 30-2. Today we're going to look at our logarithm laws. Now, in order to look at that, we're going to first review some exponential laws and what's happening. Because logarithms are just essentially the inverse of exponents, or it's solving for our exponent laws, right? It's solving for the exponents. It helps us solve for the exponents. So it's relating to the exponents. So I want us to think about that as we do this. When I do this here, if I say with the same base and we're multiplying them, so we have 5 and 3, what does that give me? This is just 4 to the power of 8. Now, here I'm dividing the same base. What do I have to do? I'm going to subtract. That's 5 to the 1. So we subtract my exponents. Here we add it. Here again, we have the same base, and we're multiplying. So therefore, I have to add these together. So I'm going to get 3x plus 2x, which is equal to 3 to the 3x, right? Now we're going back to this one here. We're dividing. Same bases, key thing there. And my exponents, what do we do? If we're dividing, we subtract. So that's equal to 6x minus 2x, which gives me a total of 4 to the 4x. Okay? Now the last one here, also we have different bases. Now if we have different bases, we cannot combine these and put them together. They need to be the same base. Now with that thing being said, we're going to relate that to our log laws. So now remember, our log laws are a bit different. It's the opposite. Here, what did we do? We added the exponents, right? So logs is solving for the exponents, and we want to know what we're doing with our base. Now here we look at it, we're subtracting. Well, what caused us to subtract exponents? If we were subtracting exponents, like right here, what were we doing? We were dividing with our inside. So our answer is dividing. So every time we have a subtraction side, and notice they are the same base, we're going to go log in base 2, 12 divided by 3 because of the subtraction. That is right here in your formula as well. When we do subtraction, it's equal to that. It's very related to our quotient law with exponents, except when we subtract, it causes us to compress it together and divide. Whereas in exponent laws, division causes us to subtract. That's the quotient law, okay? The exponents. All right? So let's look at this one here. It's a little bit more complicated, not too bad. First, we're just going to work left to right. So first we look, they're all in base 6. That means we can't combine them, okay? So we have 9 and 8. What does that mean? Multiplication, because we are adding them, right? What must we have done to add exponents? We must have multiplied. So this means we're going to multiply these here together. So I'm going to have log, it's all in base 6, 9 multiplied by 8. And then we subtract 2. So that means then we divide that by 2, because in order to subtract exponents, we must divide. Okay? Well, what does this give me? This is the same as log base 6, and we have 9 times 4 is 36. All right? Okay. So now, we're going to look at this next question here, which is just a little bit more complicated. It says, use the laws of logs to represent this as a single logarithm. So we're going to represent this whole equation here as a single logarithm. So first of all, they're all in base x, so that's nice. Now what must we do first? We still follow BEDMAS, brackets first. So I'm going to do that piece there. So I have log x 10 plus log x 75. So we still follow our BEDMAS. Then here we have to minus. Now what is this here? I'm just going to do the brackets right now. We have 2 plus. Now to add, if we're adding exponents, what does that mean we were doing before? If we ended up adding the exponents, we were multiplying. Remember, these are to help solve for the exponents. These are always equal to what the exponent is. So if we were adding, that meant we were multiplying. So it's going to be the same as log, the base x of log, 2 times 3, which is equal to 6. Okay? So I'm going to continue this out, and we're going to end up getting log all these in base x. Okay? Now this here, the adding, in order to add logs, well, that means or in order to add exponents, that must mean we're multiplying with bases. So we have to multiply these together. So that's going to give me and 75 multiplied by 10 all over, and then subtract, that must mean we're divided, all over 6. So we continue this, and I'm going to get 750 divided by 6, so 25 multiplied by 5 is 125, okay? Now it says, if x is equal to 5, evaluate. Alright, so we have log 5, 125. So much easier to do this and then compare it to that, right? That looks very messy. And I don't know if 5 to the power of what is equal to 2. I can't figure that out. But I can figure out 5 to the power of something when it's equal to 125. So that's saying 5 to the power of x is equal to 125. Therefore, x, this is the same as 5 to the power of 3 is equal to 125. So this is 3. Okay? So my answer there is 3. Or we could have typed it into our calculator. Right? Because it's very difficult, I'm going to go back to this, to do, I don't know what, 5 to the power of what is 10? I don't know what that is. I'm going to have to guess. 5 to the power of what is 2? I have no clue. 5 to the power of what is 3? No clue. That will take forever. But once we simplify it, it makes it a lot easier. Let's take a look at number 3 here. It says, the expression of this is equivalent to, well, we have a plus. That means we are going to multiply. Okay, so we go x multiplied by 2x, that gives me log 2x squared. Then we divide by x squared. That's going to leave me with log 2 Oh, and what is anything? If I have log 2 to the power what is 2? 1. So my answer is D. Alright? Now we're going to look at number 4. It says, determine the value of log log 2p minus 3 log. So we have this log here, and we're subtracting this equation there. Alright? So, first of all, these are the same. So we want to determine the value of that if p over q equals 8. Well, first, if we're subtracting, that means this is 3 log 2, and we're dividing. Subtracting means division, p over q. Okay? So what does that mean? We said that this is actually equal to 8. Because remember, subtraction means dividing. For subtracting exponents means we have to divide. So we're going to end up getting 3 log 2, and then there's an 8. 2 to the what is equal to 8? 2 to the power of 3. So we're going to end up getting 3 multiplied by 3, because this is equal to 3. 2 to the power of 3 is equal to 8, which is equal to 9. So that's my answer. Okay, so the next part here, it wants you to investigate our power law. So that's power to a power. Welcome back. Hopefully you went over that investigation there. And now we're going to look at, and you should have came up with this power law. Okay? So basically all that means is if there's an exponent, we could put it down in front. So right here we have log, this is base 10. Okay? Base 10 x, so base 10 of log x to the power of 10. Well, if we follow the formula there, what it means is we put the 10 in front, and we have log x, and that's it. So it's 10 in front of log x, okay? Because power to the power means multiplying. So here, we have to multiply it as well. If we have a power to the power, we're just going to multiply. It's kind of the same thing, okay? So right here, we have log, I'm going to rewrite this out. This is in base 10. Log, we have x to the 1 over 2. So we have a power in our thing. in our equation. So I'm just going to move this 1 over 2 in front. So I'm going to get 1 over 2 log x. Okay? That's it. Now here, we're going to work in reverse. We're just switching them and working in reverse. So let's take a look at this. This is just going to be, this must go on top. That's our exponent. Anytime we're multiplying by something, it is just our exponent. So I'm going to end up getting log x to the 5. This one here is going to be log x to the negative 1 over 3. Let's try and look at the next one. Now the next one is we want to evaluate. So here's why it's good to do this. If I say log 2 to the 8 squared, well 8 squared is 64. It's hard to think of 2 to the power of what is 64. But I could think of 2 to the power of what is equal to 3. And then I'm just going to put this in front. If I have 2 log 2 to the 8 and base log 2 to the 8, well 2 to the 8 is 3. So that is 2 multiplied by 3, which is equal to 6. That makes it a lot easier than saying 2 to the power of what is 64. Well, that's 2 to the power of 6, but it's a lot easier to push that 2 in front and multiply. I hope you see that. So let's try this one here. Ah, there already is a number in front. So it's saying 6 log 49, and then we have 7. And this 3 here, we have to move in front. So 3 multiplied by that. So now we have a double multiplication front. So it's going to give me 18 log 49 to the 7. Now 49 to the power of what is equal to 7? If I square root 49, that's equal to 7. So this here, square root is the same thing as 1/2. Okay? So that's going to be 18 multiplied by 1 over 2. So 3 over 6 is 18, because if I square root 49, that is 1/2. Now I have 18, my answer is going to be 9. Now we're on C. It says, we have this here. Now what does this part here? If we say the cubed root, that's the same thing as saying 1/3. So we have 6 multiplied by 1 over 3 log 49 to 7. Well, what's 1/3 of 6? 1/3 of 6 is 2. We're able to put this because cubed root is the same thing as saying 1 over 3. Alright? So we have what log 49 to 7, that is the same as 1 over 2. Right? Because we have to square root 49 to get 7. Thus we get 1. Almost done here. Next one is log 6. And we have that n there, so let's put that n in front. Log, or base log 6, or base 6 log 6, or 6 to the power of what is equal to 6? 6 to the power of 1. So it's 1 multiplied by n, so my answer is just n. Okay? Hopefully we're getting this. Alright, last question. Use the power law of logarithms to prove that that is equal to 2x. Okay, so let's try. So we have our one side, 2x. That's our simple side, and we're going to simplify our more challenging side. Now this, we have an exponent there. I don't like that exponent, so I'm going to put this x in front, right? And we're going to have log 4 16. So this is saying 4 to the power of what is equal to 16? Well, 4 squared. So that's x, and this is all equal to 2, because 4 squared is equal to 16. So x times 2 is equal to 2x, so this is the same as 2x, 2x, and that works. Okay? So, I hope you understood the assignment, and maybe you have some very good questions for tomorrow. And I'll see you tomorrow as we work on this assignment together. Good luck.